6.3. In this sections, we're gonna be reviewing special product, how to factor those cases. So that would be like perfect square trinomial, sum and difference of square, and sum and difference of cubes. So first, let's talk about perfect square trinomial. How do we determine it is a perfect square trinomial? So that would be 3 steps. First, you're going to check your very first term is a perfect square perfect square or not. So here's your first term. Is that a perfect square or not? You're going to have to check that. That's the first step. And then the next step, you're going to check your last term is a perfect square or not. And that will be the second part. And finally, you're going to have to check your middle term is twice the first time last or not. That will be the third things that you need to check. If these 3 criteria met, then you know that it is a perfect square trinomial. So you will have 2 of the factors are identical. Therefore, it can only happen when both of the factors are positive and both of the factors are negative. Okay? And we talked about in the previous sessions, how do we know both of the factor will be positive and both of the factor will be negative. Remember that we check if the third term is a positive. Okay, that tells us it will be both positive if the middle term is plus, and if it is both negative if the middle term is negative. So now, before we look at the other example, let's try to go back and then review a few examples. So let's talk about example number 1a. Okay. So first thing that I need to check is the very first term a perfect square or not. Yes, it is, because 49 is a perfect square number, z square. So therefore, I can rewrite this first term, okay, as 7z to the second power. And also, this last term, 1 is a perfect square number, because 1 squared is 1. Now, what we need to check is the middle term. The middle term is basically 2 times first term times last term. So that means 2 times 7z times 1. That gives me what? 14z, which is the middle term. That makes it this trinomial a perfect square trinomial. And when it is a perfect square trinomial, you can you can quickly write down the factor. So these will become your mental math part later on. You don't need to show me the work. You can write down the answer right away, which my final answer will be first minus last squared, because both of them is identical. Or you may write it down as 7z minus 1 times 7z minus 1. 2 of the term is the same thing. Okay, so you have a choice of how you want to write it down, either in exponential format or this format, multiplying to binomial format. So let's look at on the next example. The next example tells us 9a squared. So 9 is a perfect square number. A squared, so that will become, I can see that 3a squared. That's going to be my first. Right? Rewriting it. And then 64 is also a perfect square, which is 8 times 8 is 64. So it'll be 8b quantity square. Now what's left over is we need to check the middle part. Is the middle part 2 times first, right, times last or not? So 2 times 3 is 6. 6 times 8 is 48. A, B, which is the middle term that we need. Again, this portion will be mental maths part later on. So finally, I can say that my final answer for this will be a perfect square trinomial, which will give us first plus last quantity squared, because this is both positive factor. Or you can write it down as 3a plus 8b times 3a plus 8b. Write it out. So either way is perfectly okay. Now move on to the next, will be sum and difference of square. So how do we determine the sum or difference of square? If I can rewrite sum or difference of square, you only have two terms. Sum and difference of cubes, also only two terms. Okay. So let's take a look at on this. If you can rewrite first square and minus the last square, so you see that the difference of two squares, then your factor will be first minus last and then first plus last. So basically, once we get into this format, okay, once you can rewrite into this format, then the formula is just basically follow up, and that's what we want to look at it. And similarly, when you talk about sum and difference of cubes, okay, but let's take a look at sum and difference of square first. Okay, and we know that if it is sum of two squares, then it is not factorable, it is a prime. So let's take a look at on examples. C, we can rewrite, we notice that there's only two terms. The first term is a perfect square number, which is p squared, so I can rewrite it as p quantity square, minus my last term, right? The second term, which is the last term, 169, which is 169 is 13 square, right? So 13 times 13 is 169. You can check that. It's always a good idea you memorize those perfect square number, so that way you don't have to punch it in the calculator and figure it out. So now I have my first and I have my last. So according to the formula, that will be first minus last, first plus last. That would be my final answer. So these these sum of the two squares, sum of difference of two square, sum of two cubes, difference of two cubes is basically testing you, do you remember the formula or not, and being able to, like, write it out, the factor. So let's continue on the next example. 196 is a perfect square number, which is a 14. Square is 196, so that will be 14 q to the second power. I can rewrite it this way, right? Using the properties of exponent. Minus 225 is basically 15 square. So now I can see that this is difference of 2 square. Using the formula, I can write down my factor right away, which is first minus last, first plus last. So basically, this is the formula that we talked about earlier, and then I just rewrite it into first square minus last square, first square minus last square, and then I can get my factor right away using the formula once we know the first and last. Okay, so moving on to the next one. So 256. So 256 is basically 16 times 16, 16 square. That's a perfect square number, right? And then 289 Now by this time, hopefully you can see the pattern that I'm trying to give it to you. 17 times 17 is 289. Hopefully you memorize these numbers along the way on the examples. So this will become 16 r to the second power minus 17 s to the second power. So I can rewrite it into this first square minus last square format. So my first is 16r, my last is 17s. Now plug it into the formula, first minus last, first plus last, and this will be my final answer. So as we move on, we start reviewing, a problem on top of another problem, which means we're gonna have to use all the factoring techniques together. Like in example F, I only have two terms, but this is not in difference of two square format because 2 is not a perfect square number, 18 is not a perfect square number. But however, whenever you factoring, you have to consider GCF first all the time. So if you see this problem, my GCF will be 2. So when I factor 2 out, this will become t to the second power minus 9. So now this leftover binomial is a difference of 2 squared because t squared minus 9 is also a perfect square. So which I can rewrite as 2 t to the second power and then 3 to the second power, looking at my first and last like that. So now using the formula I can factor it out, first minus last and then first plus last. This step is not necessary. Okay, if you can see difference of 2 squared, you can jump from here to there for the final answer. And this factor 2 must be bring it down on every step because this is a part of the problem, so you cannot leave it out. So this is like combinations of what we talked about in previous sections and this section. Next one, 9u squared. So 9 is a perfect square number. But what about 729? Okay, 729 is basically also a perfect square number, but what you need to always consider is there any greatest common factor or not? So 729 is basically 9 times 81. You can easily check that by using your calculator. 729 divided by 9. If it goes in evenly, you know that this is the greatest common factor. So now I know that 9 is the greatest common factor. Since we are factoring completely, I have to factor 9 out first. That will become u squared minus 81. Notice that the number got smaller and then much easier to continue. And clearly u squared minus 81 is a difference of 2 squared, which is 9 times u minus 9 and u plus 9. And notice that I skipped that little mini step that we took before, which is I mentally look at this will be my u square, and then this will be my what? 9 square is 81. Okay, so I clearly see what is my first and last, right? So that way I can move on quicker. And this will be my final answer because I cannot factor any further. Continuing the next, you can take a look at this in a new format, which is this will be my first is a binomial now, uv plus 3 square minus my last will be 49 is a perfect square number, which is 7w quantity square. So now we can basically factor out using the formula, which is first minus last times with first plus last. And if you take it out the parentheses, this will be my final answer. Similarly, the next one, x minus y squared, that is a perfect square binomial. 121 is also a perfect square number, which is 11 squared. So I can look at it as my first as x minus y, and my last as what? 11 squared. So using the formula now, that will become first minus last, and first plus last. And this will be my final answer. So basically, you should put a notes like this. This will be your first, and this will be your last. And then somehow it got erased it. Let me try this. Okay. So now this is your first, and this is your last. This is your first, and this is your last. Okay. So let's continue on the next problem. A to the fourth power. So how do we write a to the fourth power as, a difference of 2 squared? Because I can look at a to the fourth power as a to the second to the second. Remember, exponent to exponent, we multiply the exponent together. So therefore, from this one, I can say that it will be a to the second power minus 16 is a perfect square number, which is 4 to the second power. So now I can see that this is my first and this is my last. So using the formula, I can factor it out. First minus last times with first plus last. Now, it's not done yet, because notice that a squared minus 4, that is also a difference of 2 squared. So I can look at it as this will be a to the second 2 to the second power. So therefore, my final answer will be, factoring that part, will be first minus last times with first plus last. And then you need to remember to bring it down the left another factor, which is a squared plus 4 is a sum of 2 squared, a prime number you cannot factor. So a squared plus 4 is that. This will be my final answer in this case. So going to the next example. Similarly, you can see that b to the fourth power. So we can look at b to the fourth power as b to the second power. So rewriting this, that will become b to the second minus 81 is 9 to the second power, perfect square. So using the formula, that will help us to see that first minus last times with first plus last. Similar to the previous problem, b squared minus 9 is a difference of 2 squared. So we can factor this out, which is first minus last, and then first plus last. Because as usual, you can look at this as b squared, and then 9 as 3 to the second power. And this portion right here is not factorable, right? Sum of 2 squared. So we need to write it down as part of the final answer. So this will be my final answer. Now, on a continuation part, we're going to connect with this sections, the first sections together. Okay, 6.1 and 6.3 together. In 6.1, we talk about factor by grouping, but we only reviewed its grouping 2 terms and 2 terms. Now that we already reviewed more factoring techniques, I can extend the grouping in terms of 3 and 1. So how do I know when to group 3 terms and 1 term? You have to be able to recognize 3 term is a perfect square trinomial, and then 1 term is a square by itself. So by saying that, if you take a look at on this, c squared minus 2c plus 1, that is a perfect square trinomial. C squared is a perfect square. 1 is a perfect square. The middle part is 2 times first time last. So that's how you can recognize you have to group 3 terms and 1 terms by itself. So when I group this, take a look at this. My first term will become c minus 1 square. Okay. And then I have minus d square. This problem is nothing different than the example I that we saw before. So continue factoring, this become a difference of 2 square. I can see that this is my first and this is my last. So I can say that first minus last, first plus last. And this will be my final answer. So make sure you put a note right here when you grouping 3 terms and 1 terms, right? 3 and 1. Then 3 must be a perfect square trinomial. That's the type of problem that we're going to look at in this sections. So continue on the next example. And I have 4 terms, and that tell us we're going to have to group what? Factor by grouping. And noticing that the first 3 term is a perfect square trinomial. And that allows us to group 3 terms and 1 term. Once again, how do I check perfect square trinomial? My first term is a perfect square, my last term is a perfect square, and the middle term is 2 times first time last. Okay? So this is e squared, this is 8 squared. E times 8, 6, and then times 2, that would be 16e. So that's how we figure it out. So now that we know this is a perfect square, review the perfect square trinomial clearly. So this will become e minus 8 to the second power minus f squared. And this is the difference of 2 square format, which is my first minus last, and then first plus last. So it's very important that you have your formulas next to you so that you can, follow what I'm talking about right now. Right? You have to remember the formula and you have to see it. So let me write it down for your notes purpose. Here's your first, here's your last. Right? Your first and last. So continuing on the next problem. And again, we have 4 terms, so I have to do by grouping. And when we start talking about grouping, we have to consider grouping 2 by 2 or 3 by 1. And noticing that this is a perfect square trinomial, then we group 3 and 1. So 3 terms and 1 terms. So again, this is basically 3g squared, perfect square. This is basically 4 squared. This part you have to do mentally, okay? And then the middle term is 4 times 3 times 2, which is going to be 24. Okay, good. So now we know that our first is, so this will become 3g minus 4 quantity square. minus h squared. That makes the difference of 2 squared, which is my first minus last, and then first plus last. So again, put in a note, this is your first and this is your last. And this will be my final answer. So the continuation example will be difference of 2 cubes and sum of 2 cubes, those type of problem. So let's go back and then look at the formula first. Okay, let's go back and then look at the formula first. Difference of 2 cubes and sum of 2 cubes. The formula, the pattern is the same, except the sign pattern changes. So it's always going to be first, what we want to do is we want to rewrite into these formats. Okay, first cube minus last cube, or first cube plus last cube. And after that, you just plug it in your first and last into the formula, which you have to remember. So difference of two cubes, the formula is first minus last, first square, first time last, plus last square. Sum of 2 cubes, the format is the same except the sign pattern changes. So notice that first square plus last, first plus last, and then first square minus first time last plus last square. Okay. So this is how you can remember your sign pattern. Okay, let's look at this. Your very first factor will be always the same as your original sign, and after that you will always have the opposite, and then the last one will be always positive. So this is how I remember: same, opposite, always positive. So look at this: same, opposite, always positive. So let's go back to factoring difference and sum of 2 cubes. So first we need to notice that there's only 2 terms, and the first term is a perfect cube numbers, and then the last term is a perfect cube numbers. So in this case, I can see that x to the third power, that is a perfect cube. 1,000, that is also a perfect cube, which is 10 to the third power. Now I know what is my first and I know what is my last already. And what I will do is I will put it into the formula. The formula said that first minus last. And this is what I will always do. Write it out first. First square plus first time last plus last square. Writing out the pattern of the formula. Then plug it in your first and last. Here's first, first time last, and then last square, which give us my final answer, x minus 10 times with x squared plus 10x plus 100. Remember that same sign, opposite, always positive. So let's take a look at our next example. 8 is a perfect cube number. Oh, I'm sorry. If I've been saying perfect square, please correct that to perfect cubes, right? So this will become 2k to the third power minus L to the third power. So now I know that here's my first and here's my last. So using the formula, it will be first minus last. Now the second part, I will write it down the format first. First square plus first time last plus last square. Now, write it in what is your first and last. So finally, my answer will be 2k minus L, 2k squared, which is going to be 4k squared, plus 2k times L will be 2kL plus L squared. That will be my final answer. Continuing, 27 is a perfect cube number, 64 is also a perfect cube number. So this will be 3m to the third power minus 4n to the third power. So using the formula, first minus last, first square, plus first time last, plus last square. So this will be 3m times 4n, and then 4n squared, which gives us 3m minus 4n, 9m squared, plus 12mn plus 16n squared. And that would be my final answer. R. Example R. 125 is a perfect cube number, which is 5 to the third power. And 216 is also a perfect cube number because 6 to the third power is 216. So this will become 6b to the third power. So using the formula, that will be first minus last, and writing the pattern, first square plus first time last plus last square. So this will be 5 times 6b, and then 6b squared. So which will become 5 minus 6b, and then 25 plus 30b plus 36b. That will be our final answer. So this is difference of two cubes. Now let's take a look at on the example of sum of two cubes. Okay, so d to the third power, that's a perfect cube number. 343, that is 7 to the third power is 343. So it'll be plus 7 to the third power. Now you can see that your first and your last clearly. Your first is d, your last is 7. So according to the formula, first plus last, and then first square minus first time last plus last square. So this will be d times 7 and 7 squared. So my final answer is d plus 7, d squared, first square, minus first time last plus last square, 49. And remember the sign pattern, same, opposite, always positive. So continue the next one to 512. So guess what number is going to be 512, which is 8 to the third power. That is 512. So this 512 is a perfect cube number, and then we only have two terms, so therefore I can rewrite it as 8h to the third plus k to the third, sum of two cube format. Now using your formula, right? Using our formula, that will be first plus last, and then it will be first square minus first time last plus last square. So that will be 8h times k, and then k squared, which my final answer will be 8h plus k. 8h squared will be 64h squared minus 8hk plus k squared, which will be my final answer. So now well, we see that sum and difference of cubes already, so we're gonna combine, with the GCF and then all of this material. So looking at this, 2 is not a perfect cube number, so what we have to do is consider the greatest common factor. And we know that 1458 is divisible by 2, which is going to be 2 is the greatest common factor, and we got x to the third minus 729. Now the question is, is 729 a perfect cube number or not? So 9 to the third power, that is 729, which is a perfect cube number. So we can rewrite it as 2 times x to the third power and then 9 to the third power, so that I can see clearly what is my first and then last in this case. So this is my first and this is my last. So now using the formula to factor this out. So 2 times, don't forget that 2, okay? 2 is a factor. 2 times first minus last, and then first square plus first time last plus last square. So now that we got used to with this formula, you can write it down along, right, when you read it out loud. So finally, this will become 2x minus 9 x squared plus 9x plus 81. That will be my final answer. Similarly, next one, factor out the greatest common factor, 3 out. This will become x to the third minus 192 divided by 3, which will be 64. And we know that 64 is a perfect cube number, right? Which is 4 to the third power. So according to the formula, it will be 3 times first minus last first square plus first time last plus last square. So finally, my answer is 4 times x minus 4, x squared plus 4x plus 16. That will be my final answer. Once you get used to it, formulas, this step is not necessary. You don't need to write this step down. You don't need to write this step down. You can go from here to here, from here to here, the answer right away. Okay, but I would recommend you practice this step by step first, so that way when you start skipping, you can clearly see or understand what's going on, okay, using the mental method. So let's continue on to finish up these sessions. Okay? Here is the last example. So notice that the first term is a perfect cube, but it's a binomial. So same idea as before. You'll be looking at x minus 3 cubed plus 1,000 is 10 to the third power. So right here you can see that this is my first and this is my last. So according to the formula, that will be first plus last first square minus first time last plus last square. So if you continue simplifying this, this will become x minus 3 plus 10, right? Take it out the parentheses. And using the shortcut formula to multiply this out, this will become x squared minus 6x plus 9. Well, you can FOIL it on the side work, okay? X minus 3 squared is x minus 3 times x minus 3, which will be x squared minus 3x minus 3x plus 9, which will give you x squared minus 6x plus 9. Same thing. So whichever you want to, approach it, that's fine. And now I'm going to distributing the negative 10, that will become negative 10x plus 30 plus 100, because 10 squared is 100. So finally, my final answer will be x plus 7 when you combine it like term. On the second part, it will be x squared minus 16x plus 139. And this trinomial is not factorable, and that will be my final answer for this one. So similarly, you can do example x. Okay, so let's do example x. So I messed up on spacing part. Right? It's a little bit too much. So example x. Let's take a look at on this. So here, this is my first, and this is my last. So according to the formula, right? According to the formula, I can say that. Let me first plus last and times with, right? Times with, I will not have space, so I will write it down right here. First square minus first time last and plus last square. So when we try to simplify this, taking out the parentheses, there will be a minus 4 plus b, and then times with, right, times with the second part using the shortcut formula right here, that will become a squared minus 8a plus 16. Distributing b, negative b right here, negative ab plus 4b plus b squared. And you cannot simplify any further, so this will be your final answer for this particular one. And that will conclude our sections.